Welcome back to the YouTube channel, An American Professor. And this is part 2 of my lecture series on Numpy. So let's get straight to it. We're going to pick up where we left off. Now we're entering into the part of the Numpy course on array methods. In the last lesson, we covered attributes. So we reviewed attributes of arrays such as size, or dot size, and dot shape. Now let's get to the methods. Some useful ones are dot to list. So you can convert an array directly to a list. Dot to file. You can write out an array to a file in either text or binary format. Binary is by default. You can dot fill an array, so you can fill an entire array with a single scalar value, say like 42. And if you do that, dot fill 42, it'll convert every element in the array to 42. You can reshape an array, you can transpose an array, and you can flatten an array. Next. Now let's upgrade our 1D array to a 2D array example. So with this, you have to have list of list notation. So your first list is your first row, 2, 0. And then your second list is your second row, 0, 2. This is just how, or similar to how you would write a matrix in linear algebra. If you've had a linear algebra course, you know, but just think of it as a two-dimensional chunk of data. And this array is 2 by 2, so 2 rows and 2 columns. And we can print out our 2D array. We will study the methods mentioned before for our 2D matrix in specific order to do something useful with the methods. Soon, we will cover automatic means of creating matrices, like how to populate common arrays. For larger matrices in research, we generally have our function populate an array. We never would code it by hand like in these smaller examples. These are just to teach you the notation of arrays and get you accustomed for how to operate and work with them. So using some array methods, let's reshape our array. So we can call dot reshape and do -1 to say we want to put it all in one dimension. So it'll do it row by row. It'll take this row and then it'll put this second row right beside the first row. Similar, we could have reshaped it to a column vector if we put -1, 1, or a row vector if we did 1, -1. We can also flatten an array to get the same result. So we call dot flatten on our array underscore 2D variable name to get the same effect as just reshaping it using that notation. So let's create an asymmetrical matrix. Notice if you transpose this matrix, so -1, 0 goes here and 1, 1 goes here, you do not get the same matrix if you call transpose. A symmetric matrix is a matrix in which if you transpose it, it's equal to its original form. And that's not the case here. So you can play around with that, transposing a matrix. A shorthand notation, instead of calling the dot transpose, you can just call dot t on a NumPy matrix, a NumPy array. It does the same thing. Converting array to a list, you can call dot to list. We have this 1, 2, 3, 4, 5. 4, 3, 2, 1 array. So we've got a 9-element array. We can convert that to a list. And I'm also printing out the type so you can see it's of class numpy.ndArray at first. Then when I convert it, I also call the type again to see that, in fact, the array was turned into a list. You can save array data to a file by calling the .to file method. And here I'm saving it as a text array, and I'm comma separating each element of this array in my file. And after I did that, I checked my file directory in Jupyter, and I did confirm that the array was stored in this text file, which I called my_array.txt. Similarly, you can read from a file using np.fromFile. Shortly, I'm going to cover methods I actually prefer to use when I save NumPy arrays. And then load arrays, I use .save to save a NumPy array to file, and .load to read that data back into a program when I want to use it. And let me show you that right now. So we define our array called my_array, and the notion for np.save to save an array is -array, the file name, and then you put in the array as a second argument to this function, which is a method of the NumPy package. This method is more common and easy to load from .mpy files too. So loading, you just call np.load on that, excuse me, .mpy file. These methods are great when you're working with projects, and for us, we'll use them when we're creating simulations and loading data. That's it for this lesson. In an upcoming video, I'll show you some handy automatic array creation methods that are useful for creating very large arrays. Don't forget to hit that like and subscribe button, help the channel grow. See you soon.